Okay, so again, there's questions over here. Questions 1, 2, 3, 4, and 5. And if I were just scanning over that and I was saying, what looks like the easiest question to do, I'm going to say, 1 doesn't look bad, but a little complicated. 2, 3, 4. I'm going to say 5 looks the easiest to do for me. So what I'd like to do is like to go through 5 first. I need what I call low-hanging fruit, a confidence builder. Then write this down, 13 plus root 2. And this is a nested root problem, by the way. And let's write this over here, 3 plus root 2. I can multiply by the conjugate of the bottom. That's going to be 3 minus root 2. And the top would be 3 minus root 2. Now, I suspect it's going to be easy to do. If not, I have to do some really kind of manipulative work to get rid of the nested root. That can be done, though. And you get plus 7 times 3 minus root 2. And on bottom, what would you get? It's a conjugate, right? So you can get 9 minus 2. Let's keep going. This is 13 plus root 2. 9 minus 2 is 7. And so 7 cancels 7. So what am I left off with? Plus 3 minus root 2. Well, things are starting to shape up. What do you have here? This just be root 16. And root 16 is just the number 4. So that's low-hanging fruit. It's a confidence builder, and we got that right. Maybe we didn't. Maybe I should look at the key. All right, I always say we shouldn't be so confident that we get a right answer until we look at a key. They put the work down there. They put the proper answer down, 4. All right? Now, someone says, if I use a calculator, could I get that? Of course you could, but the point is not to use a calculator. So I'm going to keep looking at the problem set, and I'm going to look at something that looks easier for me to do. Again, your mileage may vary. You may say something looks easier than the other. I'm going to look at 1. I'm going to see 1 doesn't look that bad. And I guess what's called a base change formula. So log base A of x. I can change this to any base I want. So, let's say I want to change it to log base B. Well, that would be x over log base B of A. All right, base change formula. Now, someone says, why do you want to do that? I got different bases all over the place. Let me point out what I mean by that. This is base 3, base x, base 2x, and base x. I'm going to rewrite everything in terms of base x. Let's write this down. Log base x over log base x of 3 times log base x of 2x times log base x of y over log base x of 2x equals, well, I'm going to use a log, the exponent rule over here, because I definitely want to get just a simple base x over there. So it's going to be 2 log base x of x. So I'm kind of looking through this thing, and I'm going to start canceling things. Again, with the assumption these logs can be evaluated, but I see no reason why I couldn't make that assumption. There'd be some values I could do that. Certainly I could tell you that x has to be greater than 0. I'd also like to tell you that x can't be 1. All right. So what I'm going to do over here is I'm going to divide both sides by, let's see. I noticed something right away. I'm noticing this cancels off. Conditionally, of course. They can't be 0. And let's see what else happens over here. I'm seeing this, if I divide both sides by this, as this goes. And I'm left off with something pretty simple now, at least I believe I am. On the right side, I'm left off with log base x over log base x3 equals a number 2. I'm sorry, I made a mistake. That's y. I'm looking at this skier here. That's what's left. All right, let me rewrite that as log base x of y equals 2 log base x of 3. Okay, let's keep rewriting it. Log base x of y equals log base x of 3 squared, which is 9. So now I know y is 9. Let's check and see how we did. Yep. And they used the base change formula to do so. Let's keep going. And again, I'm going to erase. I'm really kind of done with this. Now, when I say I'm done with it, I'm not saying that that's what I, do on an exam. I wouldn't erase things, but I'm just practicing, right? I did good with that. If I submit that, I'd be confident that I did okay in that. All right. Yeah, of course, I might have made a mistake, and a good grader catches mistakes, by the way. Let me erase this. I did this one over here. I can make a decision now on what to do next. 2 looks tough. 3 looks somewhat manageable, and 4 would require that I know something. And I'll tell you what it would require for me to know in number 4. I would need to know what the geometric mean is. If I didn't know that, I couldn't do the problem. So they say B is the geometric mean between A and C, which means B is the root of A times C, which means that B squared is equal to A times C. All right, so what they want to do is they want to show that this would give me this, with the understanding that this is a given. Let's write this down. I'm going to take the left side and multiply it out. So what do you get? A squared. I'm taking the A now. Minus AB. Right? And then what? Plus AC, right? And I'm going to take the B. And what do you get? You get AB. Let's see, minus B squared. I'm very careful, right? And then plus BC. All right, now I can take the C. What do you get? AC minus BC plus C squared. Well, let's keep doing this. Let's see. Some things disappear, don't they? So let's write down what we get. A squared. Whoops, let's go back to black ink. I'm just doing this stuff over here. Minus B squared. Well, gee, this disappears, plus C squared. Oh, boy, what do you get? A squared plus 2. And what's AC? It's B squared. Minus B squared plus C squared. What do you get over there? A squared plus B squared plus C squared. That's what we wanted to get. We got it. We did it. All right, let's take a look at the K, the number 4, and see what they did. Well, they talk about the geometric mean, and they did exactly what we did. Okay? Again, I'm talking through this, though. If you're reading the blue area, no one's talking, right? All right, let's take a look. And let's see what's left to do now. Let me get my eraser out. I'm going to start to erase things that I don't need anymore. And I did 5, right? I did 4. I didn't do 2 and 3 yet, though. So I need to make a decision. I'm going to do 3. Now, I like about 3 because I'll be honest with you, a lot of times I can't remember things. But I'm looking at these things over here, and if I look at this thing over here, it says a regular triangle, regular quadrilateral, regular pentagon, regular hexagon, each have interior angles measured in integer degrees. Then they give you the figure 13, page 41. I'm seeing it. So I'm just going to remind you that this over here, this is 60, 60. You get the idea, right? 90, 90, 90. This over here is, 108. I don't want to keep writing that in, but 108, 108, 120, 120, 120, 120, 120. You get the idea? All right. So I'm going to write the sequence down. And what do I see? I'm gonna actually sum all the interior angles, right? And the first guy, if I sum those, it would be, I'll write this down. This is a 3-sided figure. I put A3 down. And the sum of the interior angles is going to be 180. All right, and how many sides are there? There's 3 sides. And that would give me the 60 degrees. Now let's do the 4-sided figure. And what would you get over there? Well, you get 90, 90, 90, 90, 360 degrees, right? Over 4 sides. Let's do the one with the 5 sides, right? Well, that's not so bad. It's 108. And there's 1, 2, 3, 4, 5. There's 5 sides. And that's going to be 5 times 108, right? That's 540, isn't it? Again, I'm trying to find your sequence over here. And A6, well, 6 sides. And that's 120. There's 6 of those angles, right? That's going to be 600 and 120, 720 degrees. I want to generalize this by saying AN. And that's going to be N. Right? You see that each time, right? And put on what I mean by that. All right, what do you get on the top, by the way? Well, let's talk about it. This is 1 180. This is 2 180s. This is 3 180s. And this is 4 180s. So I'm going to say it's N minus 2 times 180 degrees. And that's the measure of this angle over here. You can check that if you want, but I'm going to simplify it. And so AN is equal to, let's write this down, 180 degrees N minus 360 degrees, and we're dividing by N, right? And so AN would be 180 degrees minus 360 degrees divided by N. All right, let's make sure I don't do any mistakes here. Well, let's see. Let's just check it out. If N is 3, what would you get? 180 minus 120, which is 60. Now, if N is 4, what would you get? You get 180 minus 90, which is 90 degrees. That's good. Now, let's say N is 5. That's more difficult, isn't it? So let's just see if we get the right answer. Let me erase all this business over here. All right. And it's 5. So let's see. 5 goes into 360, right? How many times? Let's see, 36, 72 times, right? And 72, yeah, 108. Miracle. Let's do the next one, 6. That's 60. Yeah, this works out beautifully. So I got my formula. Now, question, what's the question? All right, the question is, oh, by the way, you may have known that formula, but that doesn't matter to me. If you know it, you're ahead of me. It says over here, regular triangle, blah, 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 blah. In total, how many types of regular polygon have interior angles measured in degree measure? Integer. I'm sorry, integer degree. So I got to count the divisors of 360. The integer divisors of it. So I'm going to go through that with you. It's a little complicated, but I have to do it. So I'm going to look at the number 360. I can start dividing it. Well, 2 goes in. That's 180, right? And 2 goes into 180, 90. And 2 goes into 90, 45. I'm done with the 2s. I'll do 3s now. That's 15. And 3 and 5. So let's write this down. 360 is 2. Let's see, 1, 2, 3 to the third power times 3 squared times 5 to the first power. Well, I got to start counting divisors now. And the way that I do that, I could say, I have possibilities over here. And how many choices do I have for this guy over here? Well, I really have 3 choices plus 1. And let me tell you why that is. I could pick no 2s, 1 2, 2 2s, and 3 2s. That's 4. All right? How many choices on the next guy? How many 3s could I pick? Well, I'm going to say I could pick 2 plus 1. Let me go through that with you. The 1 represents no 3s, and then I could pick 1 3 and 2 3s. Now for the 5s, well, I could pick no 5s or just one of those 5s. So this is the number of divisors I'd get in total. Let's write this down. These are total number of divisors, by the way. Total number of divisors. And that's going to be what? 3 plus 1 is 4. 2 plus 1 is 3. And 1 plus 1 is 2. And what would that give me? That would give me 8 times 3, which is 24. But you know what? What I start to realize is that I got to be starting, I can't be choosing some of the divisors. For example, I'll tell you what I can't be choosing. I can't be choosing the number 1 or the number 2 because I would not have a polygon. So I really have to discount these 2 here. So of these divisors, I have to remove 2. And so I'm going to say 24 minus 2, which would give me 22 regular polygons. All right, let me show I've answered the question, and then we'll go to the key. And we'll see if I've done that. I did get the formula. Let me go back to that 180, 360 divided by n. I'll tell you we got that over here. Again, some students knew that. It's great if you knew it. I would say I can't remember a lot in life. I have to derive them or think about them. And then they got 22. All right, they did the same method we did. All right, so I got one last problem to do. I'm going to look at my blue area to do it in. I'll read it to you, though. It says the roots of ax squared plus bx plus c are r and s. Well, I want to understand what that means to me. Let me erase this over here. So the roots of that over there would be what? Well, it would be quadratic formula, right? X equals, let's see, minus b plus or minus b squared minus 4ac over 2a. So I'm going to say, r and s. So I might want to say, I'll use this letter r, by the way, because I have a hard time writing the other r. Just write big R. is equal to minus b, I'll write this down for you, plus b squared minus 4ac over 2a, and I'll say s is minus b minus the root of b squared minus 4ac over 2a. All right? Now, I do know what r and s are. They're roots of this over here. So I want to just go through things that your algebra teachers might have discussed with you. And they might have discussed with you the product and the sum of the roots because they have nice patterns to it. And it's something you should be familiar with, especially on a competitive exam. So I'm going to talk about the product of these two things here, and I'm going to talk about the sum. Now, what's easier to do? I would say the sum is easier to do. So if you were to add those two together, I'll write this on the side for you. If I were to add r and s together, well, they got a common denominator of 2a. And what would you get? Well, the roots disappear, and you get minus 2b. All right, is that correct? Yeah, so what do you get? The sum of the roots would just be minus b over a. Okay, that's written right over here. All right, I want to do the product of the two roots, r times s. And what would you get there? Well, if I multiply the bottoms, you'd get 4a squared. Well, what's nice about this? Multiplying these guys together over here, they're conjugates. So what are you going to get? You're going to get, let's see, you're going to get b squared. The two middle terms disappear, and then you get minus the quantity b squared minus 4ac. And what does that give you? R times s, and this is a formula your algebra teacher might have derived, would be 4ac over 4a squared. Well, the 4's cancel, and one of the a's cancel, and you get c over a. So your teachers may have given you these formulas. They talked about as a product and the sum of the roots. That's a way sometimes people used to check. All right, so let's see what they got. I'm going to say, we just derived those. I'm going to just erase my, review material of math, the algebra, okay? Erase this over here. Now, the next thing they talk about another quadratic. And they say it has r squared and s squared in it. So I need to figure out what that is in terms of what I have, because I notice they want to know what p is in terms of a, b, and c. So what I want to do is I want to take r plus s, which I know to be minus b over a, and I'm going to square it. And so why are you squaring it? Because I see the r squared and the s squared. So let's write this down. So you get r squared plus 2rs plus s squared is equal to b squared over a squared. Okay? So r squared plus s squared is equal to b squared over a squared minus 2rs. Now, so why'd you do that? Well, I see that over here. Let's write this down. So r squared plus s squared is equal to b squared over a squared minus 2c, I'm using this, over a. So r squared plus s squared is equal to, well, I got a squared in the bottom, right? And you would get b squared minus 2ac. All right? Now let's see what their question is. Their question is, Well, I got to read this now, don't I? So they tell me the roots. Well, let me find the roots of that. So what are the roots of x squared plus px plus q? Let's write this down. Oh, you know what? Maybe I got the answer already. Let me just read it to you. I don't know if I've seen those roots. Let me see. For the roots of r squared. Oh, what must p? I have to find out what p is. I'm sorry. I do have to work on that. So let's put this down. X equals, let's see. Let's see, minus p plus or minus p squared minus 4q over twice a, which is 2. All right. So let's see if we can write this down. Oh, let's see what I'm going to do here. I got to go back and read the question again. So find the roots, for the roots of this thing to be r squared and s squared, what must p equal in terms of a, b, and c? Okay. So they tell me the roots are r squared and s squared. So I'm going to put down r squared is equal to minus p plus p squared minus 4q over 2, and s squared is minus p, whoops, that's not right, minus p minus root p squared minus 4q over 2. Well, you know what? I'm going to add this together. R squared plus s squared, which I know what it is already. And what does this give me? Well, if you add that together, it's going to come out of 2. And what would you get? You would get minus 2p because those roots are disappearing. So let's take a look. Now, what's r squared plus s squared? Well, I already did that. It's right over here, right? Let's write this down. So what do I get? I get b squared minus 2ac over a squared is equal to minus p, right? Yeah. Let's keep going. And let's multiply both sides by minus 1. So p would equal 2ac minus b squared over a squared. All right, we found p in terms of a, b, and c. Let's see if we got it right, though. Yep, we got it right. So we did all the problems, all right, every single one. Now, granted, let me just repeat this. I'm not saying that if this was a timed exam, you'd get all of them. All right, now if you had prior knowledge of the exam and they gave you this one, you'd get all of them. I hope you realize what that means. If you knew the test and you studied it before the test, you should be able to get all the questions. Now, granted, if there was a large number of questions and you studied a large number of questions, you'll still not be able to get it, by the way, but you're familiar with them, right? So, like, for example, I'm familiar with these things because, I wrote this document. I haven't really looked at these problems in years, though. But, and I can answer it. A lot of times when I can't, even a day later, I can't remember what I've done, all right? And I do things differently sometimes. But it's manageable, all right? But don't be discouraged if you're looking at this saying, I can't answer this question or that question. What are we looking for? Your ability to try. That's what we're looking for. Can you try? And trying is really important. But anyway, if you need to reach out to me for any reason, my email address is Bannon, B as in boy, the @ symbol, NNON.US. All right, if you see an error, let me know. If you have a comment, let me know, blah, blah, blah. Thank you for paying attention.